So you see that the audience is very diverse, and this is expected. It's a good thing. And it emphasizes that when we talk about climate change, it can be seen from very different perspectives. And also when we talk about the science of climate change, still there are very different perspectives. And of course, the underlying science is unique, but the way it is studied, interpreted, and the focus on specific details changes a lot depending on your subject. In the past, I was used to have in this course also students from the Faculty of Medicine, because climate change is also much related to the health of people and the global health, and also the health of the environment. This means, in this class, apparently there is a mix of, I think you are all engineers. I don't think if I'm not missing something, there are people studying other degree programs. And but of course, engineering is also very diverse. So there is a good representation of architectural engineering, civil engineers, industrial engineers, electrical engineers. These fields are all related to climate change. This means that also the way in which we interpret this lecture is different, and I try to, in a way, to adjust the target. The first thing that I would like to say is that this is not a very quantitative subject. What do I mean? I mean, if one looks at the science of climate change, the mathematical development can be very complicated. And this is not really a course that is looking into the mathematical details. This is not a course where we will learn equations, how to apply the equations. No, this is not the subject of this course. So there are other courses if you are interested in at the University of Bologna. There is also a degree program in physics, focusing on the physics of climate. And this is not the purpose of this course. The purpose of this course is to focus on the concepts and the implication with a way of teaching that is mostly narrative. There are some quantitative parts of it, but not many. So I just want to clarify what is the broad organization of the subject. On the other hand, I am very sensitive to your comments, observations, and maybe specific requirements. So if you have anything that you would like to be dealt with some more detail, just let me know, because we can find together a way of integrating maybe some mathematical details without bothering too much the other people. So I'm very open to your suggestion. Usually, in this course, I have a good feedback from students, because it seems like the people that are passionate of this subject, people that are interested in this subject, are also quite keen to establish conversations, interactions. Actually, interaction is what I am looking for, because I want to make sure that I also meet your expectation. But let me say that don't be surprised if you will not see, and especially at the beginning, with some heavy equations or some heavy details. It's more kind of focusing on, as I said, on the concepts. This first hour is dedicated to explaining to you how the course works. So I'm not teaching anything in the first hour, but I'm giving a lot of logistic details, which I think are important. The first thing, all the lectures will be recorded and made available. Actually, all the lectures will be delivered in streaming. You see that the lectures are given in streaming, okay? So, okay, it seems like you already... And streaming, actually, I don't think it is very important, because what is important to say is to say that attending the lecture is not compulsory and doesn't give any additional preference to you in terms of of the exam or passing the exam. Is absolutely not needed to attend here. But on the other hand, and it is not needed, and if you don't attend, I think you are not interested in the streaming because you have also the recordings. If you don't attend, usually students who don't attend, they look at the videos later on if they are interested. On the other hand, I am convinced that the interaction between us is more successful if you attend in physical presence. And also, let me say that I don't make any preference, but I like the students to be in the room. So even if I am in principle in this course allowed to give some lectures in streaming, usually I don't take this opportunity, only streaming, I mean. I always come into the room because I think that the interaction is important. It's not important for passing the exam, but I hope that you are not just interested in passing the exam. Of course, passing the exam is your first priority. But on the other hand, I think that if you are here and you are attending in physical presence, it's because you want to learn. And I think that learning is much more successful if, and especially about this subject, climate change, which is a bit complicated. It's not only diverse, it's also controversial, as you know. So I think that learning is more successful if you come here. And so just keep into account that you can skip some of the lectures, no problem at all. You can even decide to not to attend, no problem at all for passing the exam. On the other hand, my suggestion for you is if you want to take advantage of this subject in your CV, if you want to take advantage of this subject with a job interview, my suggestion is, if you can, attend in physical presence and give me interaction, give me suggestions. Let me know what is your target by attending here. And this reciprocal shaping of the content and the way they are taught, which is not a detail, will allow you to profit much from this experience. Okay. So given that the lectures are recorded, and this one is recorded, these details that I'm now giving to you will remain recorded in the video. I will tell you in 5 minutes where to find the videos, etc. Okay. So if you need any clarification or you have friends asking you what about the exam, you can of course tell them write Montanari, but probably the easiest way to get these details is to look at the video or to refer, because I have a written version of what I'm saying, to my lecture notes. So first, logistic details, where to find my lecture notes. I'm talking for myself, but my colleagues will give you analogous instructions, and for them, the instructions are very similar. So where to find my lecture notes? Of course, in Virtuale, not really of course, but virtuale.unibò.it, there is a page. If you log in into it, of course, you will see something different from here because this is my login. If you log in Virtuale, you will find if you are subscribed to this course. And if you are not, you can subscribe in Virtuale. You will find the lecture notes and everything. If you are not subscribed to Virtuale, please subscribe, because besides the lecture notes, even more important is the forum, news here, okay? And the news is the forum where if I have communications, I give these communications to you. If you are subscribed, you get an email alerting you with the content of the message. So let's suppose that one day I am delayed. I have to cancel a lecture. Usually it doesn't happen, but it may happen. So I am delayed. I send a message to Virtuale and I say, look, I am delayed. So sorry for that. I will get 10 minutes late or etc. But besides these logistics, I may also give some additional material, like additional papers, additional documents, or videos, case studies. When I find an interesting thing for you, I post it in the forum. Usually, I use two channels. One is the forum, and the other is the chat of Teams. So you see that we have here the stream of Teams. and there is a chat. And the chat remains recorded in your Teams inbox. And similarly, when a message is posted, you get communication by email. So I use these two channels. In the same way, you can use these channels to communicate with me, or you can also use my personal email at Unibo, and I will tell you later, but I think you already know it. But don't hesitate to use the forum, especially if you have something to say that may be interesting for everybody, or you can use the Teams chat. Okay? So in Virtuale, there is already a copy that is not final of the lecture notes of any lecture. And at least for me, but I think also for my colleagues, let me see. Yes, you see here, oh no, sorry. Yes, you see here. There is module 3, and then I think there is also module 2, Domeneghetti. It's already there. Keep in mind that this is preliminary. This is the material that we used last year, with some changes from last year. But of course, it has to be confirmed because we may make some changes. In particular, something can be dropped and something can be added. So here you find everything. For my part, there is a difference with respect to the part of my colleagues, because my part is just given by links. If you click, for instance, on the first lecture note, Guidelines for a Successful Learning and Exam, which is indeed what I'm talking about now, you see that there is open the web page on the teacher website, because physically the material for me is on my website, not in Virtuale. In Virtuale, there are only links. In Virtuale, I put only the things that I cannot put on my website because they are not public domain. Because my website, why I have the things on my website? Because Virtuale is not open. And I want my lecture notes to be accessible forever, not forever, but okay, nothing is forever. And after you concluded your degree studies, after you are not a student of the University of Bologna anymore, I wanted the material to be collected in a place that is accessible even after the termination of your studies, and accessible also to other people outside the University of Bologna. Because you know that today openness is recognized as a key ingredient for progress and for sustainable development. So there is a movement also by governments and the founding agencies for open data, open science, open research, for obvious reasons that we are not discussing here today. By the way, I am much interested in discussing these things, but I want to focus here on our core business. I just want you to know that if you want to discuss also about these things, organization of research, openness, diversity, I'm very much interested in discussing with you. So there is a price to pay in making things accessible to everybody, which is the license. The material that is accessible to everybody needs to be public domain. So this is why some of the things that I use, I think only one PDF file is not on my website because it's not public domain. Public domain means that, for instance, if you include pictures, if you include everything, it has to be copyright free. And this is a strong limitation for a teacher because, you know, most of the things that you find over the web, they are not copyright free. And I'm not allowed to include them in my open access material and lecture notes. But what you find on my website is open and you can reuse it. Of course, attribution is, appreciated, but it's the only thing that you need, because if you want to copy and paste pictures to put in your thesis, in your reports, that's fine. Everything is open. In general, it's not like that. You know that you have to be very careful in cutting and paste from the web to, for instance, your thesis. Unfortunately, we had some serious problems sometimes with students who did that in completely good faith. But of course, they got fined because what you find on the web, in principle, is not copyright free. This is something that, and something that you need to care about. And the situation is much complicated because different countries have different laws. So, I mean, just trust for this purpose only the things where you explicitly find copyright free. So CC BY 2.0, so 3.0, 4.0. Okay, so let's jump to my website then, and this is my website. Let me just go back a little bit. This is my website, and you understand the purpose why then I have my own website and my teaching material is there. It's openness. There is also to say that you know, the university website is not very flexible because it has to be really well protected in terms of security. So it's not flexible. In my website, I am free to include links to everything I would like to link. And so this is a second reason. So in my website, under lecture note of university courses, you find here lecture note for science of climate change. 2025, I think I was wrong here. Let me see. Or maybe, because I just created the web page. Yeah, I was wrong. So it's 2026, not 2025. I will correct it. Of course, in my website, you could find some mistakes because the lecture notes are produced by me. And if you find mistakes, just let me know. Or if you find broken links, whatever, okay? So this is the introduction, and everything is explained here. And but now I would like to discuss some specific issues. So first of all, the lecture will be given always here, at least for my part. For my colleagues, I'm not really sure, but for my part, they are given here. And for my part, they are all given on Monday from 1 to 4 in this room. This is the calendar for my part, at least what I'm planning now, which is the same calendar that you can find over the web. Over the web, of course, I just cut and pasted it. And this is the list of the tutorial documents. So let's look at the tutorial documents. The typical form of the lecture notes is a web page with a PowerPoint typically at the end. So let's see if it is here. I go to the end, you see download the PowerPoint presentation of this lecture. This is the typical form of my lecture notes. Why web pages instead of, I don't know, PDF, books? Okay. The reason is that the science of climate is really evolving a lot, really. So it's not possible to make reference to a hard reference like a book without losing information after a very short time. So I wanted something that can be changed online. And actually, I'm changing these lecture notes periodically, not every day, but you can find at the bottom of each lecture the last time I modified it. And it's really, if I had to suggest to you a book on the science of climate, and in particular the science of climate change, that is good for our purpose, I wouldn't find any meaningful title. There are several books on climate change focusing on the politics, on the economics, on the narrative of it. And but to find books that can support a university subject, actually, I couldn't find anything. And this is a trend that is also rapidly expanding. Books are becoming too static for an information that is rapidly evolving, which is a good thing. The fact that the information is rapidly evolving, it's a good thing, because also the world is rapidly evolving, and therefore we need to adapt everything of our way we deal with the natural environment, we deal with natural resources, we need to adapt continuously. And also the supporting documents, I think they need to adapt continuously. So the web pages are more flexible, and the web pages allow me to include links. And the links are very useful, in particular, when I have to refer to information that I cannot import in my website because it's not copyright free. The links are extremely important, in particular for you if you want to get an additional information besides what I'm saying. And so this is why I decided to write my tutorials in the form of web pages. Sometimes the students say, I prefer the PDF because it's something that I can more easily access. If you want a PDF, it's no problem. You just have to print out the web page in PDF format. Of course, it's not very, not very elegant, but it works. And just be sure, if you do that, to stay updated, because if you print out a PDF, then you make a dynamic information static. That's it. And depending on the PDF printer, the links may not be accessible directly from the PDF, depending on the PDF printer. So just, my suggestion is try to refer to the web page for preparing your exam and for learning. And the PowerPoint, usually I use it for teaching. It's a summary. It's a kind of resume. And my suggestion, keep into account it, is when you have to prepare for the exam or when you have to get prepared on the subject, try to avoid looking at the PowerPoint. The PowerPoint is good for refreshing, but for starting, try to refer to the web pages. And that's it, okay, about the lecture notes. In principle, everything I do is minuted in the lecture notes. So I try to avoid teaching something that is not documented by me. Of course, this may happen if you make a specific request to me, like I want to discuss nuclear energy or implication connections between climate change and energy production. I have actually a lecture on that, but if you want to get more details, then maybe that I'm following your suggestion and I'm teaching something that is not minuted. But in principle, this doesn't happen. The direct consequence of that is that in order to prepare your exam, my suggestion, just refer to the web pages. They are enough. It's even not enough for passing the, it's even not necessary for passing the exam that you look at the videos or attend the lecture. For passing the exam, the web pages are self-filling. So it's really a source of material that I suggest to you. Actually, usually during the lectures, I explicitly say what is important for an exam and what is not. In general, as a reference, keep into account that what needs to be learned by memory, unless I say that, it's not something that is required for the exam. So if by chance we teach a relationship, a mathematical relationship, that is not derived, is just put on the blackboard, keep in mind that it's not needed to pass the exam unless I say it explicitly. It's not needed that you learn it by memory. What is needed is that you get a good knowledge of the topic. This is what we try to assess at the exam. If you have a perception of what you are talking about, so if you basically got what are the concepts behind it, this is what is important. But I will talk about the exam in a minute. The videos are available in two places. One place is my YouTube channel. Of course, given that I am sorry, YouTube sometimes introduce advertisements. Unfortunately, this is a big problem of YouTube, but it looks like they only start when you start a video. And in my website, I have the playlists. So it's not yet visible. It's already, no, it's not yet visible the playlist of the lectures of Science of Climate Change 2026, because it's already there, but it will become visible only when I upload the first video, which is tonight. Okay, but you see that in the playlist there are all of my lectures for the various subjects, and you will find here also the videos of Science of Climate Change. Usually I upload the same day, but please, before sending me an email asking why the video is still not there, wait a couple of days, because it may happen that I am a bit busy, and if not Monday night, maybe I upload on Wednesday morning. So just wait a couple of days. After a couple of days, if you don't see the video, maybe that I forgot. So you are much welcome to send me an email. Okay. Second place where to find the videos is Virtuale. Let me see, probably I already missed it. So let me go back here. In Virtuale, okay, and if you look on the web page of the course here, you see on the right, there should be Panopto, okay, Panopto here. In this box, Panopto, you will find the videos. Of course, it's empty now, but you will find the links to the videos. The videos are the same videos that are uploaded over YouTube. And given that they are videos that, let me share the screen 1 second, because I forgot. I need to share the screen, otherwise in the video you don't see the screen. Okay. So in the box there is nothing, but you will find. Okay, I was saying the videos are simple. They are not edited, so just keep it in mind. As they are recorded, they are put online, and they are conceived for being uploaded over YouTube. So they are just video. They are not like Panopto videos that put together different sources and you can select if you want to look at the screen, if you want to look at the camera. So they are just videos where the screen is recorded, and that's it. And in the videos, there will be some breaks because this is another important information. What I propose to you, we have 3 hours to teach, is to start always at 1:15, sorry, 1:15, teach for 1 hour and a half up to 1:15, 2:15, 2:45, and then 15 minutes break, and then from 3 to 3:45. If you want to make a break also during the first block, so like 45 minutes plus 15 minutes break, it's fine to me. You just have to agree between you and tell me, okay? I can manage, I am flexible. But if you don't say anything to me, I will start at 1:15, 2:45, 15 minutes break, and then 3:45. And that's it. And then I forgot what I was saying, but this is fine. And I don't think it is. Yeah, the video. During the break, I will not turn the video off. I just will turn off the camera and the micro, because I don't want to forget to restart the video when I come back, okay? Unfortunately, it happened several times. So when you watch back the video, when you get to the break, just move forward 15 minutes, and that's it, okay? The videos are not edited. Okay, so for the videos, we are all set. Let me move forward. And let me get back to here. Now, let's talk about the exam. First of all, exam dates. We cannot make any exam until the end of the lectures. I still have to check the calendar. I think usually it's beginning of June, like first week of June. Okay, and even if we finish the course earlier than that, we cannot record any exam before the end of the lectures. And therefore, we will schedule our exams soon after the first one. The first call will be soon after the end of the lectures, presumably around June 10. Okay, the date will be communicated to you within like 10 days. Give me the time to talk to my colleagues. We check when we can manage. And then we need to book the lab because I'll tell you later, but we will make the exam in the lab. And so we need to book the lab and then we will tell you. How many calls? Before summer, we will make 3 calls and it will be one around June 10, typically another one after 2 weeks, and another one around the 15, 20 of July. There will be a 4th call in September, and then another call in December and January 27. So 6 calls, 3 before summer, 1 in September, and 2 in December 26, January 27. This is our calendar. Usually we are flexible, but not too much because we cannot, for instance, schedule any exam during lecture time. And we can make an exception, but we have to ask permission. It's a bit complicated. So we are flexible, meaning that if something goes wrong and you have a deadline or you have to leave for go back to your home for the Erasmus students, we can manage to schedule one more exam. But just keep in mind that once we communicate the dates, and it will be soon, before the end of February for sure, just check if you have any hiccups, inconvenient problem. Let's talk about this as soon as possible, because as I said, we are flexible, but there are some constraints. In particular, for the Erasmus students, it happens every year that somebody has to go back to their country before the first call, before the end of the lectures. This is quite a problem. So if you see that it's something that may happen, last year, unfortunately, I got really a serious problem with an exam that was canceled by the university because I gave the agreement to make the exam online. I'm not allowed to. So when the university realized it, they canceled the exam. It was a bit tedious because, you know. So if you see that there might be some problems because you leave before the end of the lectures, you leave before the first call, or you may leave after the first call, but maybe that you are not happy with the outcome and you want to take another exam because you declined the vote, you declined the mark, and then you want to get a second chance. Keep in mind that you have to be here to take your exam. We are not allowed to make any exception also for Erasmus students. The exam is in physical presence. Okay. Just so if you foresee some problems with that, let's discuss as soon as possible, and we will try to find a solution together. But just keep it into account, and before booking your flights back, just check about this. And this applies to all the courses, not only mine. So be careful, because you may find some teacher like I was last year who is willing to, okay, let's hope that the university accepts it, but in principle, we are not allowed, and not only in principle. Last year I realized that also formally, and the university canceled the exam. So how we structure the exam? It's a quiz. It's a quiz with mostly composed by closed answer questions. So there is a question and there are 4 or 5 possible answers, but there might be also some exercises in the quiz, of course, very simple ones, okay, very simple computations, something that can be done with by mind, but also with a pocket calculator, of course. And there, in the quiz, there might also be some textual question where you need to provide a textual reply, okay? Mostly, as I said, closed answer section questions, and the closed answer questions are any question is referred to what we teach and what is included in the lecture notes. So basically, for getting into a question, a topic must satisfy two requirements. It was presented in the room physically and must be accessible in the lecture notes without following the links. Okay, perfect. Given that it's a quiz, we will take the exam into a lab. And depending on the type of lab that we find, if there are no enough PCs, usually there are enough PCs, but if there is some particular situation, we may allow you to take the exam on your own device. But please take into account that usually it's on the PC of the lab. The PC of the lab allows you to access, of course, the web page of the quiz. And in some of the cases, it doesn't allow you to access any other website. So don't assume that you can navigate the web when taking the exam. And of course, you cannot navigate the web with your own devices. But you are allowed to take prints out and to consult prints out with you. This is our strategy. So if you want to bring your notes, if you want to bring the PDFs from the lecture notes, you are allowed to use them. But besides it, you are not allowed to navigate the web. A complicated situation is, can I use my tablet to navigate the PDF that I downloaded? Short answer, try to avoid it, because it's a bit problematic, because we have to make sure that the tablet is not connected to the web, and we are strictly required, if the students don't follow the guidelines, to suspend the exam and to invite the student who didn't respect the guideline to leave the room. So let's just try to get prepared to avoid embarrassing situations, okay? And so please, given that there are not many printouts, just try to print out the PDF, to print them. It is no more than like 50 pages, okay? My suggestion for you, our experience with the quiz that we started to make exams with the quiz after the pandemics, our suggestion is that the better results are achieved by the students who don't need to consult the notes. And of course, you may say this is obvious, but it's obvious, but it's a fact. So it's not that consulting the notes allows you to take a 30 to get the max mark if you are not well prepared. If you are not well prepared, unfortunately, consulting the notes takes time. Some students get a bit confused because where is the note where this question was dealt with? The first one, no, the second, no, maybe the third. So it's my suggestion, try to either get well prepared if you want to get a very good mark, or on the other hand, try to reach your target by relying on yourself only. This is also good training for your future, because when you go to an interview for a job, you are usually not allowed to consult lecture notes. You have to be very prepared for the interview, and depending on your target, of course. So if your target is just to pass and you are not concerned about the mark, of course, you know your target, get prepared for reaching the target without lecture notes. And then, if you have the opportunity to consult lecture note, maybe that you get some more. This is fine. But for your target, so if you really want to get the laude or the max mark, my suggestion, try to get prepared by yourself. Because if you need to look at the lecture notes, usually the quiz is about 30 questions for half an hour. It's plenty of time if you are prepared. Our statistics say that the good students complete the exam in 10 minutes usually. So it's plenty of time. But on the other hand, if you're not well prepared, it's not really a lot of time. When the exam is finished, usually we don't make any oral examination, but there might be some exceptions. And oral means that maybe that for some of the questions we ask you, let's discuss this question because we are interested in knowing why you decided to select this answer and not the other ones. It may happen just because sometimes, the quiz, I think, is a very good way of assessing the preparation of a student. But when you really want to get into the details of something that is related to a human activity, it cannot be delegated entirely to artificial intelligence. And to use a term that is very popular today, and it cannot be very automatic. I mean, in some of the cases, it can be automatic. In some of the cases, if the assessment wants to be really responding to the purpose for which it has been created, then it needs a human intervention. And sometimes we realize that, the quiz, it was not good, but maybe that the student got confused. So let's try to discuss maybe a wrong question, like, why did you decide to answer in this way? Or maybe a good question, like, this is strange that the student got it. Maybe the student got it by chance, and then we want to verify it. Okay, so don't take. The quiz granted for sure as the unique way of assessing your preparation. It is the main one. In 95% of the cases, it will be the only one. But on the other hand, please give us also the flexibility in your interest, not in our interest. I mean, our interest is just that all the students get the max mark without any problem. And this is our target because it makes our life easier. But in your interest, we try to make the evaluation flexible. And when you are given the mark in the exam, you can decline. We don't record any declined exam. So it means that you can take the exam how many times as you like, okay, how many times as you like. Our suggestion is the only thing that you cannot make is to ask us to remake the exam in a very short time windows. I'm saying this because at almost any call, I got the question, can I repeat the exam tomorrow? Or can I repeat the exam next week? Okay, you understand that this is not possible because if we give flexibility to select this option, it's not manageable. So it's simply not possible. It's not a bad will. It's just, so just keep into account that if you decline the mark, you have to come at the next call. So look at the calendar of the calls. And then, as I said, we have some flexibility for deadlines, but it is very limited. And anytime that we make an exception to the recommendation of the university, we have to apply for authorization. And we are not given an infinite number of exceptions. So just try to study the calls and get prepared accordingly. And if you think that you may decline, just keep a safe strategy. Like, okay, the first call you may decline, the second you may decline, the third, then you may get very close to a big interval before the next one. So just try to elaborate a strategy. I think that for the exam, there is one last thing that I would like to say. And the laude usually is awarded to about 5% of the students, just to give you an idea. This is the guideline that is given by the university, but in general, at the university level, these are the guidelines that are given to the teachers. And one interesting thing, when we write reference letters, usually not for students of the master's degree program, but for instance, for the PhD students, then it may happen that we are asked by the student to provide a reference letter. And it works like this. The student, usually the candidate, gives the name of the referee to the company, to the university abroad where they want to take a postdoc, and then the professor is contacted by the university, the company, and is given suggestions to write the reference letter. Some of those universities. I mostly write for universities. They require statistics like tell me what is the quartile range of the student according to your record. What does this mean? They want to know if the student is in the first 1% of my graduations, in the second 2%, and they also want to know some of them my statistics. So if I say the student is in the upper 1%, and from my statistics, it comes out that 30% of the students get the max mark, my recommendation is less useful. And this is the way some people work. So they look at the severity of the teacher, severity is not a good term, at the rigor of the teacher, and then they interpret the opinion of the teacher, the professor, accordingly. And this also used in international panels. In international panels for founding agency, usually I am considered a lenient referee. So a person who is very, maybe too mild. And they try to make a good mix. So they know that my statistics are so-and-so, a bit too lenient. Lenient, you understand what I mean? I mean, too good. The statistics are too good. Okay, it means not severe, not very restrictive. Lenient means more open to give high marks. They know that because my statistics speaks clearly, and therefore they evaluate my opinion accordingly. They also look for diversity. So what I mean is that at the end of the story, even if it's hard to believe, if we give less laudes, it's in your interest, and not in your. I mean, it's not your interest to get a laude from a professor who gives us a lot of laudes. Your interest is getting the laude from a professor that stays within the limit of 5%. This is important. And I'm also giving these details because there is a lot of I think it is reasonable. There is, I see that students tend to increasingly look to the max mark, which is fine, I mean. But my suggestion is the best way to look for the max mark is to getting prepared, not really trying to give the exam many times or trying to select the courses where the statistics are higher with respect to others. So we try to make an effort in this direction by giving 30 only to students who demonstrate a good knowledge of the topic and good presentation abilities. And look, it's not a problem of language. I mean, we recognize language problems. And it's not really a problem of language because often the students say, look, it's not my native language. And it's also not my native language, but we can recognize the problems. And but I mean, in order to deliver a good presentation, it's important to be very prepared. And keep in mind, this is even more important for interviews, for job interviews. It's extremely important to give a good presentation, and it means getting prepared. I have an interview in 1 month from now for a research project, which is something that I really hope to get, something really, it's one of my dreams, and I am preparing every day to that interview because I know that the only way of succeeding is really getting very prepared. And getting prepared means sometimes studying with loud voice, trying my presentation with my wife, my son, my brother, and my colleagues, and I don't know how many attempts I have scheduled already. Okay. I think, let me just check if I forgot something. One last thing, the interaction with my colleagues. We prepare the exam together, and usually we are the three of us attending the exam. Not always, but usually yes. And we are also talking each other about what we teach to avoid overlaps, of course. And they are also inviting people to give seminars. I don't think I will do that. Maybe, but I'm not really sure. And in general, let me finish by saying once again, you will not find a lot of math, a lot of complex things. But this doesn't mean that the subject is easier. Sometimes, as an engineer, I find it easier to speak about very specific things because I learn the math, I learn the equations, and then that's it. Instead of getting prepared on something that is more narrative. So just try to understand how to learn the concept in the best way. I think that that's it. And if I forgot something, just let me know. And the very last thing that I would like to say, how to contact me. Usually I'm not contacted much, and the reason is that I think the reason is that, okay, the reason may be that I am teaching simple things, maybe, but probably the reason is also that everything is there on the web. So really, I get very few requests of individual clarifications. But if you have any question, just contact me. My email is everywhere. alberto.montanari@unibo.it is also here. You see there is the link here. And usually I reply to all the emails that I receive by 24 hours. But if you send an email, so just don't send a reminder after a few hours, but wait a couple of days. And usually I reply to everything I get. So don't assume if I don't reply by a couple of days, send it back again, because it means that something happened. And maybe that my mailbox was too full, but usually I can manage. Any question before I start finally teaching? No questions. Okay. Actually, I forgot to say one thing. As I said, I like interaction. And in this course, and also in the others, I welcome students who would like to give short presentations to the audience. This is a very interesting way of stimulating the conversation and the interaction. What I mean is not teaching for me. This is not what we need. But presenting like a case study, something that is relevant to you, something that helps to understand how can we support with our knowledge, with the science of climate change, the solution of practical problems, it's very much welcome. How to do that? Send me an email and we schedule a 5 minutes presentation, 5, in the room, usually after the first break, okay? And you may wait a couple of weeks if you want to get oriented, but don't wait too much if you're interested. This is not taken into account at the exam. But I tell you, it's an interesting experience also for you to get used to present in front of an audience. Maybe that you already have this experience, but still the audience of a university course is something that maybe it's quite unique. And I tell you, I am used to speak in front of the public, even to many people, but anytime that I get into the room with you, with the students, I perceive a kind of excitement, of particular feeling. And therefore, I mean, why not? You prepare max 8 slides presenting what you think it is interesting. And I leave to your sensibility to understand what can be interesting. I mentioned a case study, but maybe also something different. And of course, it must be interesting. So just don't consider like discussing an article over a newspaper unless it has a clear scientific implication. So we are interested in problems, solutions, and science of climate change. So just this makes a presentation interesting. But on the other hand, you are very flexible. And usually, after the 5 minutes presentation, I open to questions and answers, and it turns out that is very interesting. Okay, these presentations are not recorded, just for making students more comfortable also in asking questions. Okay, good. So I think for the introduction, that's it. But if I am missing anything, please let me know. And now let me go to the first link. Introduction. Okay, this is actually a presentation. It's not a PDF page, but it is an exception. I like it because it's more interactive, and okay, this animated figure is not really ideal. I need to change it because it's a bit confusing, but anyway, this is my introduction, and this course talks not only about climate change, but also about climate actions. We are also talking about solutions. So this is why you see this title. Okay. Let's start from this. And what is this graph on the left? It's monthly data, global temperature, from, I think it is from 1850, it's not very clear, but now we check, up to potentially today. First thing, this website here, very interesting. Let me see if I can open it directly from here. Yes. Okay, now this is a bit updated with respect to the slide. You see from 1850 to 2025. Okay. And this is monthly, as I said. And it is, oh no, this is annual. Okay, I put the link. Okay, this is annual. Sorry, in my graph, the previous one was monthly. And it is very easy on this website to find, okay, I will tell you later, the monthly data rather than the annual data. What is anomaly, temperature anomaly? Okay, temperature anomaly means that they computed the average of the data, the arithmetic average, in a given window. Usually it is a window that starts from 1850 and then gets to 1990. It's the average of this temperature data in that window, and the anomaly is the difference with respect to that average. Is that clear? So you see zero. Zero is about the average up to a certain point. I think it is around here, but I'm not really sure. One should look at the website to see what is the average reference and the reference for the average. And then the anomaly is simply the difference with respect to that average. Okay, so you don't see here the temperature in degrees. It's just an anomaly. This is a conventional way of presenting data in science. Refer to the anomaly rather than the raw data, other than the real value. Why? There is a motivation related to modeling. We don't need really to understand in detail why, but in modeling, when we study the correlation between two numbers, if you study the correlation, the relationship between the two big numbers with slow fluctuations, you see a strong correlation. So if the number is very huge, you lose the capability with modeling of representing the fluctuations around the long-term average. And therefore, people have the idea of, instead of modeling the raw data, let's model the fluctuation with respect to the average, because in terms of modeling, we have more chances to succeed. Sometimes I found that models that seemed very good in representing the data, if we look at the fluctuations around the average, they turned out to be very poor. So this is why in science, very often we prefer to focus on the anomaly rather than, so difference from average. Anomaly is difference from average rather than the raw data, the absolute data. Okay, now let me say one more thing. This website, let me accept the cookies, gives a lot of this data. And for instance, let's refer to this graph here. You see that there is the world, the northern hemisphere, and the southern hemisphere. So you are free to put all the data where you prefer. And if we look at the two hemispheres, you see a striking difference. The northern hemisphere is warming more than the southern hemisphere, because you see that there is a warming. We know what is global warming. Every one of us knows what is global warming. But probably not every one of us knows that in the northern hemisphere, the warming is larger with respect to the southern hemisphere. What is the reason? Short answer, we don't know. Of course, you may say, oh yeah, in the southern hemisphere, there is more ocean. So maybe it's related to the ocean. So some people say the ocean is heating up slower than the land. And therefore, this is the reason why. Could be, but actually, we don't know. Another reason could be the fact that in the southern hemisphere, there is more ocean, there are less temperature stations. Yeah, it's reasonable. But again, we don't know. And this is why I am spelling it so slowly and with the emphasis. Because there is a basic principle that we have to take into account. Sometimes we assume that we know everything of the Earth system. No, there are still many unknowns. Science has not concluded its mission. It's not true that we know everything. There is something that we don't know. I make another example. You heard about El Nino for sure, because sometimes people say it's El Nino. We will see what El Nino is, but El Nino basically is related to the temperature in the Pacific Ocean. Sometimes this temperature takes an anomalous pattern. So something that we don't know why is heating up in a part of the ocean and is cooling down in another part of the ocean. Can be due to ocean circulation, can be due to different temperature in the atmosphere over the time. But the real answer is we don't know. And El Nino is very important because it's conditioning the climate in turn. So it gives droughts, it gives floods, depending on the region. Still, we don't know some of the El Nino effects, but it is something that we don't know. So every time that we think that we can predict the future in terms of climate, we should also remember that we can take a guess, but we are not sure. And this is extremely important because in terms of action, one thing is if you have a problem and you clearly identify the reason, okay? So the car is sliding, okay, the reason is that the brake is broken. Okay, it's clear. I have to get the brake repaired, the brake. But maybe they are the tires, or maybe it's a problem with the engine. And then if I fix the brake, I don't solve the problem, and I spent a lot of money fixing the brake, which was not needed. And this, with climate, is extremely important. We have to distinguish what we need with a reasonable certainty, not certainty for sure. There are some things that we know with a reasonable confidence, other things that we know with a reduced confidence. This is, by the way, the language that climate scientists use. Confidence, high confidence, medium confidence, low confidence. It's extremely important because deciding what to do depends on the information that we have and our level of confidence. And the reason for instance, for having a B plan, a C plan, is to cope with uncertainty. Because, of course, when the situation is known for sure, there is no uncertainty, we don't need a B plan. The B plan is, you know that in climate science, they talk about a B plan. We don't have a B planet, we need a B plan, because there is uncertainty. So this is the first thing that we need to know. Okay, let's go back to this website. So metric is temperature anomaly. Let's see what other metrics they have. Sea surface, ocean heat content, ocean pH, sea level rise. Okay, let's look at sea level rise. Here, the situation is much different. You see the difference. Let me go back to the previous one, okay? Temperature anomaly. Yes, to zoom. Okay, just 1 second. And first thing I need to solve is, I don't understand why I don't see it anymore. Let me just see. Okay, let me go back to. Okay, 1 second. Okay, let me do this. Okay, here we are. You asked me to zoom what? Sorry. The central part, because I have the opportunity to zoom with this tool here. Okay, okay, and this is. Let me just go back to the original one, and but your comment gives to me the opportunity to say, if you want to zoom, if you want to download, if you want to print out the picture, it's fine. Just remember this progress, and let's look at the sea level rise. You see, it's very different, because you see that there is an increase in the final part, but it's very tiny. What you see here is almost a linear trend. Linear means straight line, okay? Almost linear. And you see that this increase it started well before global warming. So if you are a careful observer, you may think, why is that? Because we think that sea level rise is given to number two main reasons. The first is the melting of the polar caps, and the second reason is the thermal expansion. But then you would expect that the sea level rise is concomitant with the global warming. Global warming started 1980, 1985. Sea level rise started well earlier. So if you are an acute observer, you may think, why is that? Short answer, we don't know. So sea level rise started well earlier, okay? Well earlier than global warming and well earlier than CO2 emissions. But on the other hand, if you look, we will see later on that after 1750, the global temperature started to increase. And it was before the Industrial Revolution, before the increase of the CO2 concentration. And then if we take into account that the global temperature actually started to increase in around 1750, then we can explain this progress here. Okay. So you see, it's a bit complicated. Okay, now to conclude with this website, so there are several other graphs here and mass balance of ice sheet. Okay, of course, this is what we are expecting. First of all, the timing starts from 1992. And unfortunately, we see that there is a decrease of the mass balance of the mass of ice of course. And let me go back to temperature anomaly. One important thing, nobody is denying the fact that the temperature is increasing. Okay, you may have heard a lot of discussion about climate deniers, climate denialists. Okay, to be clear, because it's extremely important to be objective and to avoid any discussion that is not based on facts. So nobody questions this, okay? The fact that the temperature is increasing. Maybe that there is some discussion on the amount of the increase, because depending on the measurement of temperature with thermometers during this period here, satellites plus thermometers here, depending on the density of stations, very low up to amount here, increased in the second part. So there is some discussion. Some people say, yeah, the increase is larger. We should look at the increase only in the northern hemisphere because there are more stations. Or some people say, yeah, but if you look to satellites, the increase is lower. So we should look at satellites which are distributed in measuring. Okay, but we are talking about 0.2 degrees. Here you see about an increase of about, we are close to 1.5. We are not yet to plus 1.5. Plus 1.5 with respect to 1850. We are not yet there, but we are very close. So, I mean, a difference of 0.3, 0.2, minus 0.3 doesn't make a big difference. There is global warming. This is granted for sure. Nobody questions that. Okay, so before we make the break, this website is extremely important. Extremely interesting, sorry, not important. These are open data, and you see that there is a lot of information of, for instance, also social variables, not only environmental variables, violence and war, so nuclear weapons. It's interesting. I mean, I look at this graph, I'm not sure whether nuclear, I found a graph. Okay. Here you see the distribution of the nuclear weapons. Of course, you know, you have to always take into account the uncertainty of data. Any data, any number that you get is subjected to uncertainty. And of course, when we talk about nuclear dotation, nuclear armaments, there is for sure some uncertainty. But it is very interesting, I mean. And also there is and this is what I want to show you to conclude, population and demographics. Just one second, okay. You see here, there is, just one second, I wanted to look at the world, just the world. Okay, here we are. So it's amazing. I mean, from 1950 to 2023, from 2.5 billions, we already passed the 8 billions. So this is something that is really something that we know. But of course, we have to expect changes in the environment. And of course, in terms of urbanization, in terms of use of natural resources, and also in terms of warming, we have to expect this. And it is something that, I mean, it's not negative. The fact that the population is increasing is a good thing. It means that there is an increase of peace because there is an increase of the wealth of people. Because if you look at the life expectation, which is reported in this graph, it is amazing. Life expectation is increased a lot. And therefore, if life expectation increases, it means that people are in good health, but it also means that we are increasing in number and the age of people is increasing. Okay, and this website, I think it is an interesting resource, and there are many websites of life expectancy, and there are many. You see, it's amazing. Okay, and let's take the world. Let's take the world alone. It's amazing if you look, for instance, from 1950, you see the dramatic increase. And this increase is not, unfortunately, not the same in the different parts of the globe, but it's an amazing increase. And also recently. So it's a good thing. On the other hand, of course, we have to expect changes. So I was saying there are other websites that are providing interesting data because the recent push to openness, open data has multiplied the information that is available to the extent that, unfortunately, we, in some cases, don't even know that some information is publicly available, not to speak that we don't even know how to use it. So there is really something for you to work on if you are interested in collecting data, analyzing patterns, and these are things that mean innovation, mean giving your contribution. So I'm sure that if this data were, this data can provide material for your thesis, for even elaborating some skills. For sure, finding information over the web, even with the advent of artificial intelligence, is a skill, an important skill. It has been a bit simplified with artificial intelligence for some things. For other things, maybe it became even more complicated after artificial intelligence. Okay, do you have any question before we make 15 minutes break? Good. So let's make, we meet again 3:02 more or less, okay? I stop audio and camera. Okay, so go back to the presentation and let's look at the right graph. And first of all, let me open a parenthesis about my main expertise. As I mentioned to you briefly, I am a civil engineer as background, and then I made essentially my career in the academic sector. I am not a professional engineer. I'm not working as a professional engineer. I make some consultancy for the university, but I am still working even for consultancy in the academic sector. In the academic sector, there are three missions that have to be pushed by university professors, and they are research, teaching, and public engagement, not in order of importance. This is just to say that university professors are required to make also scientific research anyway, and besides teaching and public engagement. Public engagement is also achieved through consultancy, but research is to be done in a specific field, and there is today a push towards interdisciplinarity, but still researchers usually focus on a specific field, and then those that are inclined towards multidisciplinarity and interdisciplinarity, they expand their interest. By the way, multidisciplinarity means that you put several disciplines together. Interdisciplinarity means that you put people specialized in different disciplines to work together. So it's not just putting together results. This is multidisciplinarity. Interdisciplinarity means working together. So my main field is, as I said, hydrology, the science of the water cycle. Hydrology has connection with environmental sciences in general. So I got very interested, and also I made some research in climate science. But I'm not a climate scientist. I made, in particular, research on the connections between climate and hydrology. I am, for instance, only a little bit involved in climate modeling. It's not my main field. I am saying this because every time that you interact with a teacher, you should get a perception of what is the best that a teacher can offer to you. And in order to gain such perception, you need also to study, to look at the curriculum, to look at the experience of the teacher. So this is why I'm making clear that I will make many examples related to water. And the reason is that I am an hydrologist. And if there is a field, if any, which I should indicate as the field where I have a good knowledge of the literature of the science, this is water science, hydrology. Okay. Climate science is still something that I am been working on for more than 20 years, but I'm not as expert as in hydrology. So, parenthesis closed. Water consumption, and let me check it's over the screen, because on the vertical axis there is global freshwater withdrawal for agriculture, industry, and domestic uses since 1900, measured in cubic meters, global freshwater withdrawals. There is an increase that is very close to the increase in temperature. We cannot say it's correlation, because in order to say that they are related, they are dependent each other, we should demonstrate it. But for sure, the fact that the pattern is very similar to the increase of temperature and quite similar to the increase of the human population indicates that probably there could be a connection. There could be a connection. And this means that on the one hand, it's not only a problem of temperature. If there is a problem, it's a problem of sustainability in general. Because we are looking here at water uses, but we could look at the use of fossil fuels, at the use of energy, of electricity, many things. So on the one hand, it's not only temperature. On the other hand, it's an indication that when we look for the causes of it, when we look for the solutions, we have to think in a holistic way. What does it mean holistic? It means comprehensive. We shouldn't look only at the global warming, but we should also look at all the implications and propose solutions that address, that are unified solutions, address all the problems. And so on the one hand, one could say global warming is clearly human-induced if you look at these two figures, because water consumption, for sure, there is no doubt, is human-induced. And it's related to the increase of population, and it's related water consumption to something that is very positive, because it means that people use more water, and this is an indicator of wealth. I mean, we want to minimize the use of water globally, but on the other hand, we want to maximize the water that reaches people, because it means that we want that such an increase means that water is available for everybody. So, I mean, in principle, the increase of water consumption is not negative. It is negative if water consumption is increased only in a few countries, increased a lot only in a few countries. But if it is an increase that is widespread, and we could check in our working data if water consumption increased everywhere or were increased more, if it is widespread, it's a good sign. So this means that also when we look at the increase of temperature, I mean, we shouldn't be very pessimistic. It may be also an indicator of something that is improving in terms of wealth of people, like it is for water. So, I mean, the approach must be, in a way, very, very holistic, as I said, and taking into consideration that the target could be not necessarily reducing warming. The target necessarily should be reducing the negative impact of it. And there are several negative impacts, we will see them. But on the other hand, when we look for a solution, also the solution should mitigate the negative impacts, shouldn't cause any additional negative impact, while keeping the benefit. Because the solution to make the water exploitation sustainable shouldn't be the solution of reducing the water, the amount of water that reaches the people. It should be a solution that minimizes the leakages, minimizes the improper use of water, while maximizing the number of people that can have the water into their houses. And also when we look at temperature, sometimes I see very easy solutions like the increase of temperature is caused by human emissions. Maybe, but we are not sure, once again. Or we are quite sure that there is this component, or we are sure that there is this component. But there could be other causes that we have to take into account. And then, quite often, the media say we have to eliminate the use of fossil fuels in order to reduce the human emissions, and then reduce global warming. Once again, yes, I fully agree. We have to reduce the use of fossil fuels, also because it's not good for the health, for the air quality, for many reasons. And fossil fuels are going to finish, are going to be exhausted. And therefore, for sure, we have to reduce it. But on the way of achieving to this final goal, on the way of getting to target, we have also to consider that we have to reduce the use of fossil fuels without causing negative impacts, without losing the benefit that having energy, because it's energy, remember, it's energy. It's the production of energy, it's not the use of airplanes increasing the CO2 emission, it's energy production. We have to make sure that if we reduce the use of fossil fuels, still we can benefit from more energy, because energy means wealth. So the situation is a bit complicated, and it's a good thing that it's complicated, because it means that there are solutions that could be found with additional research, with additional knowledge, and multiple solutions to it. So if we stick on only one interpretation and only one solution, it's problematic, it's a narrow view. We have to get a very large view without any preconceived opinion, understand the uncertainties, understanding the science, and then evaluating a portfolio of solutions. Because this is a problem. I mean, global warming, of course, on the one hand is posing a lot of problems, and it's a problem that requires a portfolio of solutions. There is no unique solutions to that. Okay, so this is what we are dealing with. The nice thing of these slides is that on the web they are available. They allow some interaction, and I mean, interaction is just a way of making a break. Okay, we just made a break, but it's just a way of making a break. And an interesting question is, what is climate change then? And it's a way to make a break by asking a question that seems to be trivial, but it's not. Because actually everybody talks about climate change, but when we ask people what is climate change, it is a tricky question. So here you see a series of options. It's like an emulation of the quiz that you may find at the exam, just 4, okay? And then the second part is the definition of climate. What is climate? So sometimes when I ask what is climate to an audience, I notice that it's not clear to many the difference between weather and climate, while the difference is extremely important. So basically, without asking you to reply to the question, climate is expressed in terms of statistics, and climate is given by the statistics of weather. Weather is day-to-day meteorological situation, like day-to-day temperature, day-to-day rainfall. And climate is statistics of weather. So if I say, in Bologna, every year we get about how much rainfall in terms of water depth? About 600 millimeters, 700 millimeters. This is climate. If I say tomorrow, it is predicted rain, this is weather. In fact, it is called weather prediction. When we call about climate prediction, instead, people usually predict statistics in 2050. So people say in 2050, the temperature increase with respect to 1850 will be 2 degrees. This means a statistic. And therefore, it's important to keep it into account. So when you listen to the TV after a disaster, this is an indication of climate change. It's an improper statement, because a disaster is a day-to-day event. You should look at the statistics of disasters to say it's climate change. And I will show some statistics of disasters. It's very important that we understand the terminology, because it means that we understand what are we talking about. Now, the media have also the mission of delivering a clear message. So it is appropriate that they make some simplification. But we are scientists, we talk about science, we have to be rigorous, so we have to start from definitions, otherwise we don't understand each other. And this is a main problem also in science, because when we pursue interdisciplinarity, sometimes we talk about, very often, taxonomy. It means that we have to clarify the terms that we use. Okay, so weather refers to the day-to-day, here, we should write weather refers to the day-to-day state of the atmosphere, such as the combination of temperature, humidity, rainfall, and other factors. Climates describe the weather of a place averaged over a period of time, often 30 years. Keep this into account. Climatologists say we can talk about meaningful statistics of climate when we average over at least 30 years. This is why also global temperature is sometimes averaged, because the temperature of 2025, which, by the way, if you notice in the graph, was lower, much lower than the global temperature of 2024 and 2023, it doesn't mean that we are going down. It's just a down. We will see next year, and a year later, and a year later, and they say we can say it goes down only after 30 years. Global warming started around 1990, so it's already 35 years ago. So it's already significant, also in terms of statistics over 30 years. Defining 30 is a bit, also climatologists, some of them say it's too long, let's say 10 years. Some say, let's talk about 3 years. It depends on the point of view, okay? I tend to agree that 30 years may be too much, too long, and 10 years may be enough. But when I published a scientific paper I proposed for publication by computing statistics in Bologna of weather over 10 years, the reviewers said, it's too short, you have to enlarge it. Enlarging it didn't change the results. The reviewers very often suggests changes when they don't like the result, and they hope that by suggesting the changes, the result change. Okay, so what is climate change? It's a long-term shift in weather patterns, okay? Correct. And here, check, correct, okay? So now it's, let me go back to the previous slide, or let me do like this, because I want the original question displayed, sorry. So climate change is not a global deterioration of climate, is not the occurrence of unprecedented extreme events, because if you look in the past, you can find similar events. Maybe that you have to look at the far past, but you find even worse events than those that we are seeing today. And it's not just a global increase of temperature. This is global warming, but climate change is something different. It's not only global warming. Unfortunately, global warming is quite secure. There is little uncertainty in it. In the other climatic variables, rainfall, wind speed, there is a lot of uncertainty and a lot of spatial heterogeneity. It depends on the place and the time. So when maybe you listen somebody saying there is a global increase of flooding, it's an improper statement. There are some countries that have been demonstrated where flooding has decreased, and the same for droughts. It's not clear at all if droughts worsened after climate change. This may seem amazing to you because everywhere one reads climate change will cause an increase of droughts. They forget to say that this is what models say. It's not what has been observed. In terms of observations, droughts are so infrequent that we cannot really say anything. If we look at the recent data on the contrary, it seems that droughts are decreased, maybe for increased evaporation. Acceleration of the hydrological cycle means increased evaporation, more rainfall, and therefore more water availability, because it's not only water volume that matters, it's water flow. So the fact that the flow is accelerated means more water available. And so just keep into account that we need to elaborate an opinion based on facts, and these facts are not easy to be got from the media, unfortunately. It's not easy to get them from the web, because there is a lot of information about climate change on the web, and unfortunately it's very messy, very confused. There are people saying one thing, other people saying another thing. It's complicated, and I also tried with ChatGPT, artificial intelligence. It's complicated. And so it is something that makes the field interesting. Okay, let me say also something related to the science of it. So what is the difference between change and variability? They are often confused. Change implies a long-term shift. Variability is just temporary up and down. Variability means spread. So here you can see Northern America temperature change and tropical America. So the pattern is the same, but in Northern America there is more variability. There is an increasing pattern, you see, it's clear. But in Northern America there is more up and down, more spreading, which makes the identification of the patterns much more difficult. In this case, you can recognize the pattern. There are some of the cases where is the pattern? So let's make clear the difference between change and variability. Why? Because the solutions are different. So if I have less water forever, the solution is to increase the water sources. So if I'm taking the water from a river and the river flow is decreasing forever, I have to take the water from the underground. I have to take the water from another river in order to complement, increase the sources. If the problem is variability, meaning that the summer drought is lasting more, because this is also an implication of climate change, the summer drought that is longer. So overall, over the year, the river flow is the same, but with more water in one season and less water in another season. The solution is a water reservoir. It's not using groundwater. It's just to accumulate the water when it's available, to distribute it when it's not available. But storage is not a solution if the decrease is continuing into the future, because it means that the volume is decreasing. Variability doesn't imply a decrease in volume over the long term. Everything is clear? You like the tone? Is interesting enough? Or is sleepy? Okay. This introduction is just to give you some ideas, and then of course we go into the details. So this introduction may look something like a bit fuzzy, okay? But it's just to give you an overview of what we are talking about. Okay, this is, I think, a very interesting question. So climate change is a concern, and we are quite convinced, not to say we are sure, that is human-induced. But when I ask the reason why do you think it is human-induced, then this is a tricky question. It's a very difficult question. So what is the reason why we humans believe that global warming and climate change is induced by us? And you see some possible replies. Some people say, we never saw something like this. We never saw temperature increasing so fast. So it's clear that it's related to the human influence. It's related to increase of human population, fossil fuels burning. Remember, the Industrial Revolution was 1880. So before 1880, the CO2 emissions were more or less constant by humans, more or less constant for the whole human history. It's starting from 1880 that they increased a lot. And then after 1880, there was energy production. So some people say, we have never seen something like that. My reply, it's not true, because it's true that we have never seen something like that for the past 500,000 years. But if we look, now we have paleo data, we look at the very far past, we have the long periods where the Earth was without ice caps. Actually, if we look, and I have a figure that I will show you, at the history of Earth, in terms of presence or not of ice caps, we realized that it was longer the period without ice caps. And in some of these changes, the shift was very rapid. And we are getting now clear demonstration of a rapid disappear of ice caps. So this occurred also before, and not in the past 500,000 years, but earlier than that it occurred. Another thing that people don't know is that we are in the tail of a glaciation now. And this glaciation started to retreat 11,000 years ago, which in geologic terms is nothing. I mean, of course, for us, 11,000 years is, something really long time. But in geologic terms, 11,000 years is nothing, okay? And 11,000 years ago, the glaciation started to retreat. And since then, there was a more or less continuous retreat, and since then, the climate entered into a very stable period, which is lasting also today. And this very stable period favored the growth of civilizations. Before than that, if we look at the paleo data, the climate was much more unstable. Okay, so this is also why now we think that an increase of temperature of 1 degree is something important, because we can, from quite a stable period in climatic terms, actually, if we go back into the past, the climate was much more unstable. And for reasons that we don't know, maybe impact of meteorites, maybe eruption, disastrous volcanic eruptions. And the impact of meteorites in particular is something that we cannot reconstruct beyond a certain period. We know that there are some craters caused by the impact of meteorites, but the fact that we have the atmosphere over the Earth and we have rainfall cancels these traces. So it is quite likely that past shifts were maybe caused by the impact of a meteorite, and An interesting thing is that if you look at Mars, for instance, where there is no atmosphere and no rainfall now, in the past there was a lot of rainfall, a lot of water, but in the past, like 5 billions of years, I think, you can find it on Wikipedia, there has been no water, no atmosphere over Mars, and Mars is completely covered by craters, big impact of meteorites. And maybe that some of these impacts were the cause of the disappear of water over Mars. Over the Earth, we don't have these traces because it is cancelled by precipitation. But I mean, the impact of meteorites is something that has the potential. It will occur for sure in the future, more sooner or later. And it is something that to some extent can be predicted years in advance, sometimes. And it is something that has the potential to completely change the climate, completely change the conditions of the Earth environment. But of course, if you look on a small time window, I mean, these impacts happen very infrequently. Okay, so let's forget about the first answer. It's not this. Third answer, so I'm skipping the second, and you understand that if I'm skipping, it's probably because it's the right one. The media agree on the anthropogenic forcing of climate change. Of course, this is something to be discarded, cannot be that. Scientific community agrees that anthropogenic forcing is dominant. This is true. The scientific community, the majority, large majority of the scientific community agrees that the anthropogenic forcing is dominant, is not everything. If you ask it to a scientist, do you think that global warming is only due to anthropogenic forcing, then this percentage of people agreeing would decrease. But the percentage of people agreeing that it's dominant in global warming over the other causes is very large. On the other hand, we know that consensus cannot be used in science to support an interpretation. It shouldn't be. If you are interested in this debate, look at scientific consensus over Google, and you find a lot of things starting from Galileo. And you know that the Pope apologized, Johannes Paulus II, after 500 years, apologized on behalf of the church because the church condemned Galileo basing on scientific consensus. And Galileo, of course, was right. We know this now. And the science should rely on evidence, not consensus. Consensus is politics, which is fine. In politics, it's perfect. It's completely fine. But and also in social sciences, it's very fine. But science should rely on evidence, not consensus. Of course, when there is no evidence, then people tend to rely on consensus. This is exactly the case of climate. There are some things that we don't know, and therefore we tend to rely on consensus, but it cannot be an accepted support. So the explanation is, the answer is two. Climate models cannot explain current climate change unless anthropogenic forcing is considered. This is the motivation, which is a good motivation, because models are based on our knowledge. This means that basing on our knowledge, on our current knowledge, which includes uncertainties, we don't have any other suitable explanation for climate change other than anthropogenic forcing. This is the way to say it. Of course, if you say this in this way, the message to the public is not very clear. So this is why the media tend to say it's anthropogenic forcing, because it's a more clear message. If you start saying to people, politicians, administration, well, we are convinced that indeed the solution, the problem is given by this, and then the solution is this. It's not very effective. This is a big question. So should science tell the public the truth, including uncertainty, or should science tell the public a message that is convenient to the public itself, with the risk that it becomes convenient for the politics only and not for the public? But suppose that I have a good motivation, which is looking for the public good. Should I tell the truth to the public, or should I tell something that is convenient? And look, this is a question that extends over several branches of science. And to make you a very meaningful example, how many times the medicine wonders whether to a person that is affected by a severe illness, whether it's convenient for the person to say the truth or to say something different, which is not really true, but may be convenient for the people. And then usually what they made is a psychological analysis to check whether it may, what could be the implications. For some people, knowing the truth gives more motivation to fight against the illness. Other people may get very depressed. A similar question is frequently arisen in climate science. Should we say the truth? And the truth may be, well, we are not really sure. Or should we give a message that is clearer? And this explains why, when you listen to the media, you get sometimes an idea, and when you listen to scientists, you get several different ideas. Even among scientists, there are scientists that are more convinced of solution A, others that are in doubt between A and B, others that are more convinced towards solution B. And in order to get oriented into this situation, there is one unique solution: learning. Learning. Education is the solution to get more informed and to elaborate an opinion. Okay, so models cannot explain current climate change unless anthropogenic forcing is induced. Okay, some numbers and then we close for today. Numbers are important, and some of these numbers you will find in the quiz, in the final quiz of the exam. And numbers are important because, you know, I give you an example. About 10 years ago, I attended a lecture by a very distinguished scientist, and unfortunately, he passed away later on. And he was really very distinguished, and he said, extreme rainfall is increased 10 times. And I thought this is really misleading, because extreme rainfall is increased like 10%, 20% in the worst case. I'm not going into the details, but if one asked me, in Bologna, in terms of floods, what is the magnitude of the increase? Let's make the question very, very naive. So what is the magnitude of the worsening of the situation? I would say 10%. And 10% is not nothing. It can make the difference. In some places, 10%, even 50% more, who cares? But in Bologna, which is a situation that is a bit, difficult equilibrium, even 3% more makes a difference. So 10% is an indication that, related also to the situation in Bologna, tells us that indeed climate change had an effect that you can perceive in the life of people, in damage to houses, and not really a risk of losing life, but in terms of damage, economic damage, it's significant. It's an elaborated answer, but a person who says 10 times more, which means 1,000%, I mean, it's a misleading message, because it's clear that cannot be 1,000%. It's clear, it's not 10 times more. And everybody can understand it. So the reaction that I got from several people, a person in the street, they said, oh, this is not credible. I mean, I have an umbrella in my house, and I count the number of times I open the umbrella, or I have an idea. It's not 10 times more. So it's extremely important to get a perception of the number and the implication. So global temperature is raised about 1.3. Now it's more than 1.3. This was like 5 years ago. Now we are already at 1.4. And if you look at single years, it's already more than 1.5. But when you average, because we have to average, remember, we are getting numbers that vary between 1.3, 1.4. It depends on the length of the averaging period. And it's not negligible. So don't make the mistake to say, well, what's the problem? I mean, in the summer, 1 degree more, who cares? I mean, it's not really something. I mean, if you first, there is to say that this is an average. If you look over the Alps, the temperature is increased 2 degrees. In the mountains in general, it's increased more. 2 degrees means a big retreat of glaciers. So it is something that, okay, for our skin, doesn't really matter. But in terms of a retreat of a glacier, it means kilometers of retreat, which means a lot of other things, landslides, less water during summer. I mean, it's not really tiny. We already saw that temperature increased more in the northern hemisphere. Sea level rise is about 21 centimeters. So sometimes I get a little bit puzzled when I look at the media and they say some islands are risking to be drowned. This is not real risk today to be drowned by the sea level rise. But this is average, and more or less it's equally distributed over the globe, the sea level rise. But in terms of extremes, it means more than that. And in terms of saltwater intrusion into the land, in terms of what may happen that you open the tap and you get salt water, this is really important. So 21 centimeters are important not for getting drowned, but for getting salt water intruded into the land and therefore into the water supply systems. This becomes important. Global CO2 emissions, this is really, I mean, they have raised from about 5 to about 34 billions of metric tons from 1940, which means 7 times larger. And this is really something like almost one order of magnitude. On the other hand, per capita, the increase was from 2 to 4.5, so twice, because the population is increased. So when you compute per capita, of course, the global increase in volume is divided by a larger number, and per capita, the increase is smoothed a little bit. CO2 concentration in the atmosphere increased about 25% from 1980 to 2020. You know that several simulations of climate are made for 2CO2. 2CO2, we are still far away from it, but it is increasing, the CO2 concentration in the atmosphere, and these are data. Global economic losses from weather catastrophes are steadily increasing, and now we are around 300 billions of US dollars, 300 billions of euros. When this slide was prepared, the dollar and euro were more or less at the same level. And 2023 was the hottest year on record. Actually, also, I think 2024, sorry. So 2023 was the hottest here on record. 2024 was hotter. 2025 is cooler. Okay. And on record means from 1850. Some numbers, finally, global population. Okay. And we already thought about it. Good. We see each other again on Monday, and if you have any question, meanwhile, comment, you are welcome. Grazie, thank you.